Welcome! Today we're going to talk about the quadratic formula and the discriminant. First off, here's our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In class, we derived this together, and we also sang a lovely song to help us remember it. Okay? Ask me to sing the song in class because I don't really want my singing to be on YouTube. All right? So there is a song to help you recall this quadratic formula, and like I said, we did that in class. So if you were gone, ask me about it. First off, the discriminant portion of this is the b squared minus 4ac. Notice that that discriminant portion comes from underneath the square root. Underneath the square root is going to determine what types of values we have. And why I say this, because if we take the square root of 36, well, that's just 6. If we take the square root of 2, we don't have an exact number. That turns out to be some sort of irrational number. Okay? Or if we take the square root of a negative 10, that ends up being a complex number or an imaginary number. So the part of the quadratic formula that really tells us what type of solutions we have is the number we get inside the square root. So if that value in the square root, if that discriminant there, if it is a perfect square and it's greater than 0, so it's a number like 36, 49, 64, we're going to have two real rational roots. What that means is that we're going to have two solutions. Those two solutions are going to cross our x-axis, and rational means that their numbers actually exist. Their numbers exist, and we know it written as a fraction. So for example, the numbers like 1, 4, but also things like 5 halves, 10 sixteenths, 8 ninths, etc. Those would all be rational roots. Okay. The other option, we could also have b squared minus 4ac. It's also positive, but this time it's not a perfect square. So like the square root of 2. When it's not a perfect square, it simply means that we can't take the square root of it. We're still going to cross the x-axis at two distinct points, but we are now going to have irrational roots. What irrational roots means is that our solutions are going to be like the square root of 2 or square root of 3. When we figure out what they are, they just keep on going and going and going. They never stop. They don't have any type of pattern to it. They just keep on going. Okay. Then we could also have inside of our square root, our b squared minus 4ac could equal 0. Well, if that equals 0, that means that we have negative b plus or minus the square root of 0 over 2a. Well, the square root of 0 is just 0, so we can't add and subtract 0 to get two answers. We just have negative b over 2a. So we're going to have one real rational root, and that one real rational root is negative b over 2a. If you recall, negative b over 2a, this is where your vertex should be, or your axis of symmetry, which right here, this little diagram is indicating that our parabola is hitting right at that vertex. And we have one last option here that we could have, and that last option is if we have a discriminant that is less than 0. If we are less than 0, we're going to have two complex or imaginary roots because we are trying to take the square root of a negative number, which we know gives us complex or imaginary solutions. What that means about our graph is we never actually cross the x-axis. Our solutions are complex or imaginary. So what we're going to be doing is we're going to solve quadratics. This time we are going to use our quadratic formula. So we're going to find the discriminant, we're going to solve it, and we're going to state the number and types of roots based off of our discriminant. And we're going to leave our solutions exact, so we're going to leave them in radical form. So first up, x squared minus 12x minus 28 is equal to 0. Some of you, it will be helpful for you to say a is 1, b is negative 12, and c is negative 28. And then plug it into your formula. So x equals negative b, so it'd be positive 12 plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, so 1, times c, so negative 28, all over 2 times a is 1. So this is equal to 12 plus or minus the square root of 12 squared is 144. 4 times 1 times 28 is 112. These are both negative, so it's plus 112. All over 2 times 1 is 2. Well, 144 plus 112 gives us the square root of 256 all over 2. So this tells us the value of the discriminant. So the discriminant here is 256. 256, the square root of that is 16, so this is plus or minus 16 over 2. Since that has an actual square root, we have two real roots. That's our number and type of roots. And now we're just going to finish finding the solutions. So this tells us we have 12 plus 16, and we're going to divide that by 2. And we have 12 minus 16, and we'll divide that by 2. 12 plus 16 is 28. 28 divided by 2 is 14. So 14 is one of our solutions. 12 minus 16 is negative 4, and negative 4 divided by 2 is negative 2. So that's our other solution. So there we solved that first one using the quadratic formula. Second one, x squared plus 22x equals negative 121. First off, for the quadratic formula to work, this needs to be equal to 0. So we're going to add 121 over. So this is x squared plus 22x plus 121 is equal to 0. So in this case, our a is 1, our b is 22, and our c is 121. So x equals negative b, so negative 22, plus or minus the square root of b squared, so 22 squared, minus 4 times a, so 1, times c, 121, all over 2 times a of 1. So this is negative 22 plus or minus the square root of 22 squared is 484. 4 times 1 times 121 is 484. So minus 484 all over 2, which is negative 22 plus or minus the square root of 0 over 2. This tells us that our discriminant is 0. Since our discriminant is 0, we have one real root. And that one real root we will now finish solving. Negative 22, we can't add and subtract 0 to it. We just get negative 22 back. So negative 22 divided by 2 is negative 11. So there we solve that using the quadratic formula. All right, we'll do a couple more examples. 2x squared plus 16x plus 33 is equal to 0. So our a here is 2, our b is 16, and our c is 33. So x equals negative b, so negative 16, plus or minus the square root of b squared, so 16 squared, minus 4 times our a is 2 times our c is 33. All over 2 times our a is 2. So simplifying this down, we get negative 16 plus or minus the square root of 16 squared is 256. 4 times 2 times 33 is 264. So we have 256 minus 264 all over 2 times 2 is 4. Well, 256 minus 264 would give us with a negative 8. So now we have negative 16 plus or minus the square root of negative 8 over 4. So there's our discriminant. Our discriminant here is negative 8. Since it's a negative 8, we have two complex numbers for our solution. And now we just need to figure out what they are. So this gives us negative 16 plus or minus the square root of negative 8. For sure the negative gives us an I. And then 8 would be 4 times 2. The square root of 4 is 2, so it's 2 square root of 2. So this would be plus or minus 2i square root of 2 over 4. And then notice 16, 2, and 4 all have a common factor of 2, so you can divide top and bottom by 2. which gives you negative 8 plus or minus I squared of 2 all over 2. So your simplified solution would be negative 8 plus or minus I squared of 2 all over 2. All right, and we will do one last problem together using this. Negative 5x squared plus 8x minus 1 is equal to 0. So here your a is negative 5, your b is 8, and your c is negative 1. So x equals negative b, so negative 8 plus or minus the square root of b squared, so 8 squared, minus 4 times a, so negative 5, times c, so negative 1, all over 2 times a, so 2 times negative 5. Simplifying down, this gives you negative 8 plus or minus the square root of 8 squared is 64. 4 times negative 5 times negative 1 is a minus 20. All over 2 times negative 5 is negative 10. This then gives us negative 8 plus or minus 64 minus 20 is 44. So plus or minus the square root of 44 all over negative 10. So there's our discriminant. 44 would give us two irrational numbers. It's two irrational numbers here because we do not know the square root of 44. And now we just need to solve it. So the square root of 44, we could break that down to 4 times 11. 4 is our perfect square that fits in there, so that is 2 square root of 11. So here we'd have negative 8 plus or minus 2 square root of 11 all over negative 10. 8, 2, and 10 all have a common factor of 2. And since the 10 is negative on the bottom, we'll divide top and bottom by negative 2. So this then becomes a positive 4. 2 divided by negative 2 is a negative 1, but then we have this plus or minus, so we still will have a plus or minus. Square root of 11 all over negative 10 divided by negative 2 is 5. So this is 4 plus or minus the square root of 11 all over 5. So that is how we end up using the quadratic formula to help us solve quadratics.